Hi everybody. The problems coming under the topic trigonometry is based on the right-angled triangle. Today in this video, introduction to trigonometry, we are going to see what is a right-angled triangle, which side is opposite side in a right-angled triangle, which side is hypotenuse, which side is adjacent side, how to find the trigonometric ratios sine theta, cos theta, tan theta, cosecant theta, secant theta and cot theta from the right angled triangle, how to draw the table for the standard degrees of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree for the trigonometric ratios sine theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. How to find the length of the unknown sides of the right angled triangle if the length of the two sides are given using Pythagoras Theorem. How to find the length of the unknown sides if the length of only one side and one angle is given using the trigonometric ratios. How to find the length of the third side of the right angled triangle if the trigonometric ratio with fractional value is given. And finally, what is the use of learning trigonometry? Let us go to the first question. What is a right angled triangle? As we know that a triangle has three sides and three angles. If any one of the angle is 90 degree, then it is a right angled triangle. In the triangle ABC, the side AB is perpendicular to the side BC. Therefore, the angle ABC is 90 degree. Therefore, this triangle ABC is a right angled triangle. Different types of triangles have been drawn below. The highlighted angle is 90 degree. Each triangle is having 90 degree as one of the angles. Therefore, all these triangles are right angled triangles. Now we are going to see the second question, third question and fourth question altogether. Second question is which side is opposite side in a right angled triangle. Third question is which side is hypotenuse, and the fourth one is which side is the adjacent side. As we have seen that a right angle triangle has 90 degree as one of the angles. In this triangle ABC, angle ABC is 90 degree. Angle BAC is theta. Here in this triangle ABC, angle ABC is 90 degree and angle ACB is theta. Now we shall see the name of the side for this right angled triangle ABC. We have to learn that the side opposite to theta is the opposite side, that is the side BC is the opposite side. Then the side opposite to 90 degree is the hypotenuse, that is the side AC is the hypotenuse. After naming the opposite side and the hypotenuse, the third side AB is the adjacent side in this right angled triangle. Let us go to this triangle. In this triangle ABC, the side opposite to theta is the opposite side, that is the side AB is the opposite side. Then the side opposite to 90 degree is the hypotenuse, that is the side AC is the hypotenuse. After naming the opposite side and the hypotenuse, the third side BC is the adjacent side. Thus, from these two triangles, we learn that in any right angled triangle, the side opposite to theta is the opposite side, the side opposite to 90 degree is the hypotenuse, and the third side after naming the opposite side and the hypotenuse is the adjacent side. To avoid the confusion in naming the sides of the right angled triangle, let us name the sides for these two right angled triangles. In the first triangle, the theta is at A. In the second triangle, theta is at B. In the first triangle, angle ACB is 90 degree. In the second triangle also, the angle ACB is 90°. But in the first triangle theta is at A, in the second triangle theta is at B. For the first triangle we shall give the names for the sides. We know that the side opposite to theta will be the opposite side. So in the first triangle the side opposite to theta is BC. So BC will be the opposite side. The side opposite to 90° will be the hypotenuse. So for the first right angle triangle, the side AB will be the hypotenuse. After naming the opposite side and the hypotenuse, the third side AC will be the adjacent side. Let us go to the second right angle triangle. Here theta is at B. The side opposite to theta will be the opposite side. So in the right angle triangle ABC, AC will be the opposite side. The side opposite to 90° will be the hypotenuse. That is, the side AB will be the hypotenuse. After naming the opposite side and hypotenuse, the third side BC will be the adjacent side. Thus, we have named the sides of the right angle triangle by observing the angle theta. Let us go to the fifth question. How to find the trigonometric ratios sine theta, cos theta, tan theta, cosecant theta, secant theta and cot theta from the right angled triangle. ABC is a right angled triangle with angle ABC is equal to 90°, angle BAC equal to theta. We know that the side opposite to theta is the opposite side, that is the side BC is the opposite side. The side opposite to 90° is the hypotenuse, that is the side AC is the hypotenuse, and the third side after naming the opposite side and the hypotenuse is the adjacent side. We have the formula sine theta equal to opposite side by hypotenuse. Cos theta equal to adjacent side by hypotenuse. Tan theta equal to opposite side by adjacent side. Now we have seen the three trigonometric ratios: sine theta equal to opposite side by hypotenuse, cos theta equal to adjacent side by hypotenuse, and tan theta equal to opposite side by adjacent side. Now we are going to see cosecant theta, secant theta and cot theta. Cosecant theta is nothing but the reciprocal of sine theta, that is cosecant theta will be hypotenuse by opposite side. Secant theta will be the reciprocal of cos theta, that is secant theta will be hypotenuse by adjacent side, and cot theta will be the reciprocal of tan theta, that is cot theta will be adjacent side by opposite side. Now we shall see cosecant theta. That is cosecant theta equal to hypotenuse by opposite side, which is the reciprocal of sine theta. Now secant theta is hypotenuse by adjacent side. And cot theta will be the reciprocal of tan theta, that is cot theta will be adjacent side by opposite side. Thus we have seen the 6 trigonometric ratios from this rectangle to triangle, that is sin theta equal to opposite side by hypotenuse, cos theta equal to adjacent side by hypotenuse, tan theta equal to opposite side by adjacent side, cosecant theta equal to hypotenuse by opposite side, secant theta equal to hypotenuse by adjacent side, and cot theta equal to adjacent side by opposite side. We have to keep in mind that cosecant theta is the reciprocal side of sin theta, secant theta is the reciprocal side of cos theta, and cot theta is the reciprocal side of tan theta. Now we are going to see the relation between the trigonometric ratios. 1 by sin theta can be written as cosecant theta, 1 by cosecant theta can be written as sin theta, 1 by cos theta can be written as secant theta, 1 by secant theta can be written as cos theta, 1 by tan theta can be written as cot theta, 1 by cot theta can be written as tan theta. Further, sin theta by cos theta equal to tan theta. Taking reciprocals, we get cos theta by sin theta equal to 1 by tan theta. This cos theta by sin theta can be written as cot theta because 1 by tan theta is cot theta. We have to keep all these things in mind to do the problems in future. Let us go to the 6th problem, that is how to draw the table for the standard degrees of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree for the trigonometric ratios sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. Before entering into the formation of trigonometric table, we have to learn the basic things, that is when 0 is divided by any number we will get 0. For example, when 0 is divided by 1 we will get 0. When 0 is divided by the negative number minus 3 we will get 0. If 0 is divided by 15 we will get 0. Thus if 0 is divided by any number we will get 0, but if any number is divided by 0 we will get infinity. For example, if 1 is divided by 0 we will get infinity. If minus 3 is divided by 0 we will get infinity. If 15 is divided by 0 we will get infinity. Thus we have to learn the difference. If 0 is divided by any number we will get 0. If any number is divided by 0 we will get infinity. The new thing we learn here is that a number divided by 0 is infinity, because we are going to use this infinity in the formation of the trigonometric table. Further, we have to keep in mind that tan theta can be written as sin theta by cos theta. It will be easy for us to form the trigonometric table if we memorize the values 0, 1 by 2, 1 by root 2, root 3 by 2 and 1 in this order. After memorizing these values in this order, we have to write the trigonometric table. We have to write the 6 trigonometric ratios like this: sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta, and the standard degrees 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now we are going to fill the sin theta first. To find sin 0 degree we have to write 0. For sin 30 degree we have to bring 1 by 2. For sin 45 degree we have to bring 1 by root 2. For sin 60 degree we have to bring root 3 by 2. For sin 90 degree we have to bring 1 here. For cos theta, we have to write the memorized value in the reverse order. That is, for cos 0, we have to write 1. For cos 30 degree, we have to write root 3 by 2. For cos 45 degree, we have to write 1 by root 2. For cos 60 degree, we have to write 1 by 2. And for cos 90 degree, we have to write 0. For tan theta, we have to divide the values of sin theta and cos theta. That divided value should be written in this line. Let us first fill the sin theta values. For sin 0 degree, 0 should come here. For sin 30 degree, 1 by 2 should come here. For sin 45 degree, 1 by root 2 should come here. For sin 60 degree, root 3 by 2 should come here. For sin 90 degree, 1 should come here. For cos theta, we have to write the values got for sin theta in the reverse order. That is, for cos 0, we have to write 1. For cos 30 degree, we have to write root 3 by 2. For cos 45 degree, we have to write 1 by root 2. For cos 60 degree, we have to write 1 by 2. And for cos 90 degree, we have to write 0. Let us fill the boxes with the values. For cos 0 degree, we have to write 1. For cos 30 degree, we have to write root 3 by 2. For cos 45 degree, we have to write 1 by root 2. For cos 60 degree, we have to write 1 by 2. For cos 90 degree, we have to write 0. For tan theta, we have to divide the value of sin theta and cos theta, and that divided value should be written here. For tan 0 degree, 0 by 1 will be 0. For tan 30 degree, 1 by 2 by root 3 by 2, we will get 2 will be cancelled and 1 by root 3 will come. For tan 45 degree, we have to divide 1 by root 2 by 1 by root 2. We will get 1. For tan 60 degree, we have to divide root 3 by 2 by 1 by 2. These 2 and 2 will be cancelled and root 3 by 1 will come. For tan 90 degree, we have to divide 1 by 0. That will be infinity, as we have seen earlier. Now we are going to fill the cosecant theta values. For cosecant 0 degree, we have to write the reciprocal value of sine 0. The reciprocal value of 0 is 1 by 0, that is infinity. For cosecant 0 degree, we get infinity. For cosecant 30 degree, we have to write the reciprocal value of sine 30, that is the reciprocal of 1 by 2 is 2 by 1. For cosecant 45 degree, we have to write the reciprocal value of sine 45 degree, that is the reciprocal of 1 by root 2 is root 2 by 1. For cosecant 60 degree, we have to write the reciprocal value of sine 60 degree, that is root 3 by 2. When written in reciprocal, it will be 2 by root 3. For cosecant 90 degree, we have to write the reciprocal value of 1, that will be 1 only. For secant 0 degree, we have to write the reciprocal value of cos 0, that is when 1 is written in reciprocal, it will be 1. For secant 30 degree, we have to write the reciprocal value of cos 30 degree, that is when root 3 by 2 is written in reciprocal, it will be 2 by root 3. For secant 45 degree, we have to write the reciprocal value of cos 45 degree, that is when 1 by root 2 is written in reciprocal, it will be root 2 by 1. For secant 60 degree, we have to write the reciprocal value of cos 60 degree, that is 1 by 2 when written in reciprocal, it will be 2 by 1. For secant 90 degree, we have to write the reciprocal value of cos 90 degree. The value of cos 90 degree is 0. When 0 is written in reciprocal, it will be 1 by 0. 1 by 0 is infinity. For cot 0 degree, we have to write the reciprocal value of tan 0 degree. That is, when 0 is written in reciprocal, it will be infinity. For cot 30 degree, we have to write the reciprocal value of tan 30 degree. That is, when 1 by root 3 is written in reciprocal, it will be root 3 by 1. For cot 45 degree, we have to write the reciprocal value of tan 45 degree. That is, when 1 is written in reciprocal, it will be 1 only. For cot 60 degree, we have to write the reciprocal value of tan 60 degree. That is, when root 3 by 1 is written in reciprocal, it will be 1 by root 3. For cot 90 degree, we have to write the reciprocal value of tan 90 degree. That is, when infinity is written in reciprocal, it will be 0. We have filled these boxes only by memorizing these values. That is 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Now we are going to see how to find the degree value for the trigonometric ratios. For sine 0 degree, the value is 0. For sine 30 degree, the value is 1 by 2. For sine 45 degree, the value is 1 by root 2. For sine 60 degree, the value is root 3 by 2. For sine 90 degree, the value is 1. For cos 0 degree, the value is 1. For cos 30 degree, the value is root 3 by 2. For cos 45 degree, the value is 1 by root 2. For cos 60 degree, the value is 1 by 2. For cos 90 degree, the value is 1. For tan 0 degree, the value is 0. For tan 30 degree, the value is 1 by root 3. For tan 45 degree, the value is 1. For tan 60 degree, the value is root 3 by 1. For tan 90 degree, the value is infinity. For cosecant 0 degree, the value is infinity. For cosecant 30 degree, the value is 2 by 1. For cosecant 45 degree, the value is root 2 by 1. For cosecant 60 degree, the value is 2 by root 3. For cosecant 90 degree, the value is 1. For secant 0 degree, the value is 1. For secant 30 degree, the value is 2 by root 3. For secant 45 degree, the value is root 2 by 1. For secant 60 degree, the value is 2 by 1. For secant 90 degree, the value is infinity. For cot 0 degree, the value is infinity. For cot 30 degree, the value is root 3 by 1. For cot 45 degree, the value is 1. For cot 60 degree, the value is 1 by root 3. For cot 90 degree, the value is 0. Before going to the next question, like to subscribe, press the bell button. Thank you. Now we are going to see how to find the length of the unknown side of the right angled triangle if the length of the two sides are given using Pythagoras Theorem. Here ABC is a right angled triangle with angle B as 90 degree. We have angle BAC as theta. The side opposite to theta is the opposite side. That is, the side BC is the opposite side. The side opposite to 90 degree is the hypotenuse. That is, the side AC is the hypotenuse. After naming the opposite side and the hypotenuse, the third side AB is the adjacent side. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. In other words, we can write the adjacent side square as AB square plus opposite side square as BC square and hypotenuse square as AC square. Pythagoras theorem is used to find the unknown side of the right-angled triangles only. We are going to do few problems to find the length of the third side of the right-angled triangle by using Pythagoras theorem. In the first question, in right-angled triangle ABC, angle ABC is 90 degree, angle BAC is theta. The side opposite to theta is BC and its length is given as 3 cm. The side opposite to 90 degree is the hypotenuse, that is AC is the hypotenuse, its length is not given. And the third side, after naming the opposite side and the hypotenuse, is the adjacent side and its length is given as 4 cm. That is, the adjacent side AB equal to 4 cm. We are going to find the length of the hypotenuse AC by using the Pythagoras theorem. In right angle triangle ABC, by Pythagoras theorem, sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. That is, that adjacent side square can be written as AB square plus opposite side can be written as BC square and hypotenuse can be written as AC square. And this is named as equation 1. In this equation 1, we have to put the given values AB as 4 cm and BC as 3 cm. On substituting AB equal to 4 and BC equal to 3, this equation 1 becomes 4 square plus 3 square equal to AC square. When we square 4, we get 16 and this plus is written, and when 3 is squared, we will get 9 equal to AC square. 16 plus 9 equal to 25 equal to AC square. Now this AC square on the right hand side is brought to the left hand side, and 25 which is written on the left hand side is brought to the right hand side. Here there will be no change in sign because the whole thing on the right hand side is brought to the left hand side and the whole thing on the left hand side is brought to the right hand side. Hence we have AC square equal to 25. Taking square root on both sides, we get root of AC square equal to root of 25. When root of AC square comes out, it will be AC equal to, when root of 25 is coming out, it will be 5. Therefore AC equal to 5 cm. Hence we have found the length of the unknown side, that is hypotenuse AC, as 5 cm by using Pythagoras theorem. Let us go to the second problem. In the given right angle triangle ABC, the side opposite to theta is the opposite side, that is BC is the opposite side. The side opposite to 90 degree is the hypotenuse, that is the side AC is the hypotenuse, and the third side after naming the opposite side and the hypotenuse is the adjacent side, that is the side AB is the adjacent side. The length of this adjacent side AB is not given. We are going to find the length of the adjacent side by Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse, that is adjacent side square plus opposite side square equal to hypotenuse square. This adjacent side square can be written as AB square plus this opposite side square can be written as BC square equal to this hypotenuse square can be written as AC square, that is AB square plus BC square equal to AC square, and it is named as equation 1. Put the given values BC equal to 8 cm and AC equal to 10 centimeter in the first equation. On substituting BC equal to 8 centimeter and AC equal to 10 centimeter, the first equation becomes AB square plus 8 square equal to 10 square. AB square is written as AB square plus 8 when squared we will get 64 equal to 10 when squared we will get 100. This AB square is kept on the left hand side, and on the right hand side we have 100, and when this plus 64 is brought to the right hand side, it will be minus 64. That is AB square equal to 100 minus 64, that is 36. We have AB square equal to 36. Taking square root on both sides, we get root of AB square equal to root of 36. When root of AB square comes out, it will be simply AB equal to, when root of 36 comes out, it will be 6. That is AB equal to 6 centimeter. Hence, we have found the length of the adjacent side AB as 6 centimeter by Pythagoras theorem. Now we are going to see the third problem. In the given right angle triangle ABC, the side opposite to theta is the opposite side. That is, the side BC is the opposite side and its length is not given. The side opposite to 90 degree is the hypotenuse. That is, the length of the hypotenuse AC is given as 6 centimeter. After naming the opposite side and the hypotenuse is the adjacent side, that is, the side AB is the adjacent side and its length is given as root 11 centimeter. We are going to find the length of the unknown side, that is length of the opposite side BC, by using Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. This adjacent side square can be written as AB square plus this opposite side can be written as BC square equal to this hypotenuse square can be written as AC square. And this equation is named as 1. Put the given values AB equal to root 11 and AC equal to 6 centimeter in the first equation. On substituting AB equal to root 11 and AC equal to 6, we get root of 11 square plus BC square equal to 6 square. That is, AB is replaced by root 11. AB is replaced by root 11 and AC is written as 6 and BC square is written as BC square only. When root of 11 is squared, we will get simply 11 plus BC square is written as BC square equal to 6. When squared, we will get 36. Now BC square is written on the left hand side is equal to, on the right hand side we have 36. When this plus 11 goes to the right hand side of the equation, it will be minus 11. BC square equal to 36 minus 11, we will get 25. Hence BC square equal to 25. Taking square root on both sides, we get root of BC square equal to root of 25. When root of BC square is taken out, it will be simply BC equal to, when root of 25 is coming out, it can be written as 5. That is, BC equal to 5 centimeter. Hence, the length of the unknown side, that is the length of the opposite side BC, is found as 5 centimeter by Pythagoras theorem. In the fourth problem, in the right angle triangle ABC, angle CAB is theta, angle ABC is 90 degree. We know that the side opposite to theta is the opposite side, that is, the side BC is the opposite side and its length is given as BC equal to 6 centimeter. The side opposite to 90 degree is the hypotenuse, that is, the side AC is hypotenuse and its length is given as 10 centimeter. After naming the opposite side and the hypotenuse, the third side is the adjacent side, that is, the side AB is the adjacent side and its length is not given. We are going to find the length of the adjacent side AB by Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. This adjacent side square can be written as AB square plus this opposite side square can be written as BC square is equal to this hypotenuse square can be written as AC square. Put the given values BC equal to 6 cm and AC equal to 10 cm in 1. On substituting these values, this first equation becomes AB square plus 6 square equal to 10 square. That is, AB square is written as AB square and BC is replaced by 6 and BC square is 6 square equal to AC is replaced by 10 and then square it will be 10 square. AB square plus 6 when square we will get 36 is equal to 10 when square we will get 100. On the left hand side we have AB square equal to, on the right hand side we have 100. When this plus 36 goes to the right hand side it will be minus 36. Therefore, AB square equal to 100 minus 36 is 64. AB square equal to 64. We have, taking square root on both sides, we get root of AB square equal to root of 64. When root of AB square is taken out of the root, it will be AB equal to root of 64 can be written as 8. That is, AB equal to 8 cm. Hence, we have found the length of the adjacent side AB as 8 cm by Pythagoras theorem. Now we are going to see how to find the length of the unknown sides if the length of only one side and one angle is given using the trigonometric ratios. In the given right angle triangle ABC, angle ABC is 90 degree, angle BAC is theta equal to 45 degree. The side opposite to theta is the opposite side, that is the side BC is the opposite side and its length is given as 5 cm. The side opposite to 90 degree is the hypotenuse and the length of the hypotenuse AC is not given. After naming the opposite side and the hypotenuse is the adjacent side, that is the side AB is the adjacent side and this length is also not given. Thus we have given one angle and length of one side of a right angle triangle. We have to find the length of the hypotenuse and the adjacent side. Let us first find the hypotenuse. We have the opposite side BC equal to 5 cm and theta equal to 45 degree. The trigonometric ratio related to opposite side and hypotenuse is sine theta. That is, sine theta equal to opposite side by hypotenuse. Sine theta equal to opposite side is BC and the hypotenuse is AC. Put theta equal to 45 degree and BC equal to 5 cm in the first equation. Therefore, the first equation becomes sine 45 degree equal to opposite side BC is replaced by 5 by AC is written as AC. The value of sine 45 degree is 1 by root 2. This 1 by root 2 can be obtained from the trigonometric table. Therefore, 1 by root 2 is equal to 5 by AC. By cross multiplication, we get AC into 1 is AC, root 2 into 5 is 5 root 2. Thus, we have found the length of the hypotenuse AC as 5 root 2 centimeter. In right angle triangle ABC, this length opposite side, that is the length of the side BC was given in the problem itself. This angle was given. We found the length of the hypotenuse AC as 5 root 2 centimeter. We have to find the adjacent side AB by Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. This adjacent side square can be written as AB square plus this opposite side square can be written as BC square equal to this hypotenuse square can be written as AC square, and this is given as equation 1. Put BC equal to 5 centimeter and AC equal to 5 root 2 centimeter in the first equation. Therefore, the first equation AB square plus BC square equal to AC square becomes, AB square is not known, that is written as AB square. This BC is known, so we have to replace BC as 5, and when it is square, BC square means 5 square equal to AC is 5 root 2 and it is square. AB square is written, and 5 when square it will be 25 equal to 5 root 2 is going to be squared. When 5 is squared, we will get 25. When root 2 is squared, it will be 2. Therefore, AB square plus 25 is equal to 25 2s are 50. Now, AB square is kept on the left hand side of the equation, and on the right hand side we have 50, and when this plus 25 goes to the right hand side of the equation, it will be minus 25. Left hand side we have AB square equal to, on the right hand side, 50 minus 25, we will get 25. Taking square root on both sides, we get root of AB square equal to root of 25. When root of AB square is coming out of the root, it will be simply AB equal to root of 25 can be written as 5. Therefore, the length of the adjacent side AB is 5 centimeter, and it is found by the Pythagoras theorem. Thus, we have used the trigonometric ratio at first. After that, the third side was found by the Pythagoras theorem. Let us go to the second problem. In the given problem, in right angle triangle ABC, angle ABC is 90 degree. BAC is theta and its value is given as 60 degree. We know that the side opposite to theta is the opposite side. Therefore, the side BC is the opposite side and its length is not given. The side opposite to 90 degree is the hypotenuse. Therefore, the side AC is the hypotenuse and its length is not given. After naming the opposite side, and the hypotenuse is the adjacent side, that is, the side AB is the adjacent side and its length is given as 4 centimeter. We were given the length of one side of a right angle triangle and one angle of the right angle triangle. We have to find the length of the two sides by using the trigonometric ratio. First, let us find the length of the hypotenuse. We have the adjacent side AB equal to 4 centimeter and theta equal to 60 degree. The trigonometric ratio related to adjacent side and hypotenuse is cos theta. That is, cos theta equal to adjacent side by hypotenuse. Cos theta equal to adjacent side is AB and hypotenuse is not given and its length is AC, and cos theta equal to AB by AC, this is given as equation 1. Put theta equal to 60 degree and AB equal to 4 centimeter in the first equation. Therefore, first equation becomes cos 60 degree equal to 4 by AC. Because cos theta equal to AB by AC, we substitute the theta value as 60 degree and AB as 4. That is, cos 60 degree equal to 4 by AC. Cos 60 degree value is 1 by 2. These values can be obtained from the trigonometric table. Therefore, 1 by 2 equal to 4 by AC. By cross multiplication, we get 1 into AC is equal to 2 into 4. 1 into AC is AC and 2 into 4 is 8. Thus, we have found the length of the hypotenuse AC as 8 centimeter by using the trigonometric ratio. This was the given right angle triangle. We were given the length of the adjacent side AB as 4 centimeter and this angle BAC as theta equal to 60 degree. We found the length of the hypotenuse AC by using the trigonometric ratio, and its length is 8 centimeter. Now we are going to find the length of the opposite side BC. We are going to find the length of the opposite side by using Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. This adjacent side can be written as AB and its square plus BC. Opposite side square can be written as BC square equal to hypotenuse square can be written as AC square, and it is named as equation 2. Put AB equal to 4 centimeter. This was given in the problem itself, and we found the value of AC as 8 centimeter by the trigonometric ratio. We have to substitute AB equal to 4 centimeter and AC equal to 8 centimeter in the second equation. Therefore, the second equation becomes AB should be replaced by 4 and BC should be used as BC and AC should be replaced by 8. Therefore, the second equation becomes 4 square plus BC square equal to 8 square. When we square 4, we will get 16 plus BC square equal to 8. When square, it will be 64. BC square is kept on the left hand side of the equation, and on the right hand side we have 64. When this plus 16 goes to the right hand side of the equation, it will be minus 16. Left hand side we have BC square equal to 64 minus 16 equal to 48. Taking square root on both sides, we get root of BC square equal to root of 48. When root of BC square comes out of the root, it will be BC equal to root of 48. Therefore, we have found the length of the opposite side BC as 40 root 48 by Pythagoras theorem. Now we are going to see the third problem. In the given right angle triangle ABC, angle BAC is given as theta equal to 30 degree. The side opposite to theta is the opposite side, and the opposite side BC is given as 4 centimeter. The side opposite to 90 degree is the hypotenuse. The side AC is the hypotenuse, and its length is not given. After naming the opposite side and the hypotenuse, the third side is the adjacent side. Therefore, the third side is AB, and its length is also not given. For this right angle triangle, we were given the length of one side and one angle. That is, opposite side is given and one angle is given. We are going to find the adjacent side by using the trigonometric ratio. The trigonometric ratio related to opposite side and adjacent side is tan theta. That is, tan theta equal to opposite side by adjacent side. Tan theta equal to, this opposite side can be written as BC and the adjacent side can be written as AB. Therefore, tan theta equal to BC by AB, and it's given as equation 1. Put theta equal to 30 degree and BC equal to 4 centimeter in the first equation, because this theta is given in the problem and BC also given in the problem. Therefore, the first equation becomes tan 30 degree is equal to BC value is 4 centimeter by AB is written as AB. Tan 30 degrees value is 1 by root 3. This tan 30 degrees value can be obtained from the trigonometric table. Therefore, 1 by root 3 equal to 4 by AB. By cross multiplication, we get AB into 1 is AB equal to 4 into root 3 is 4 root 3. Therefore, we have found the length of the adjacent side AB as 4 root 3 by using the trigonometric ratio. This was the given right angle triangle. This length was given, that is, the length of the opposite side BC was given in the problem itself. The length of the angle BAC was given as theta equal to 30 degree. We found the length of the adjacent side AB as 4 root 3 by using the trigonometric ratio tan theta. Now we are going to find the length of the hypotenuse AC by using the Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, AB square plus BC square equal to AC square. This adjacent side, this can be written as AB square, plus this opposite side square can be written as BC square, and this hypotenuse square can be written as AC square. And this equation is named as 2. Put AB equal to 4 root 3 and BC equal to 4 in the second equation. Therefore, the second equation AB square plus BC square equal to AC square becomes 4 root 3 square plus 4 square equal to AC square. This AC is the length of the hypotenuse, and we are going to find the length of the hypotenuse AC. Therefore, 4 root 3 square plus 4 square equal to AC square. When 4 is squared, we will get 16. When root 3 is squared, it will be 3 plus 4 when squared, it will be 16 equal to AC square. 16 3s are 48 plus this 16 is coming equal to AC square. 48 plus 16 will be 64 equal to AC square. Now we are taking the AC square which is on the right hand side to the left hand side, and 64 which is on the left hand side to the right hand side. There will be no change in sign because the whole thing on the right side is going to the left hand side and the whole thing on the left hand side is going to the right hand side. So we have AC square equal to 64. Taking square root on both sides, we get root of AC square equal to root of 64. When root of AC square is coming out of the root, it will be AC, equal to when root of 64 is coming out, it will be 8. Thus we have found the length of the hypotenuse AC as 8 centimeter. Now we are going to see how to find the length of the third side of the right angle triangle if the trigonometric ratio with fractional value is given. To know this type of problems, we have to do few examples. Here I have written 6 problems, that is sin theta equal to 3 by 5, cos theta equal to 1 by 2, tan theta equal to 8 by 6, cosecant theta equal to 5 by 4, secant theta equal to 10 by 8, and cot theta equal to 4 by 5. If we find this type of problems, we have to learn the trigonometric ratios. Before solving those problems, we have to learn the basic things what we have learned earlier, that is sin theta equal to opposite side by hypotenuse, cos theta equal to adjacent side by hypotenuse, tan theta equal to opposite side by adjacent side, cosecant theta equal to hypotenuse by opposite side, secant theta equal to hypotenuse by adjacent side, cot theta equal to adjacent side by opposite side. Let us first go to the first problem. Sin theta equal to 3 by 5. For sin theta, we have opposite side by hypotenuse. That is the formula we have written. Sin theta equal to opposite side by hypotenuse. We have opposite side in the numerator and hypotenuse in the denominator. So in the given problem, the opposite side is 3 and the hypotenuse is 5. So we have opposite side and hypotenuse. We don't have the adjacent side. We are going to find the length of the adjacent side by using Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square, and this is named as equation 1. Put opposite side equal to 3 and hypotenuse equal to 5 in the first equation. Therefore, the first equation becomes adjacent side square is written as adjacent side square because we have to find that length, plus opposite side square is 3 square equal to hypotenuse square is 5 square. Now adjacent side square plus 3 when squared it will be 9 equal to 5 when squared it will be 25. Now adjacent side square which is to be found is kept on the left hand side, and on the right hand side we have 25. When this plus 9 goes to the right hand side of the equation, it will be minus 9. Now left hand side we have adjacent side square, and on the right hand side we have 25 minus 9 is 16. Taking square root on both sides, we get root of adjacent side square equal to root of 16. Root of adjacent side square when comes out, it will be adjacent side equal to root 16 when comes out, it will be 4 centimeter. Thus we have found the length of the adjacent side as 4 centimeter by Pythagoras theorem. Now we shall go to the second problem. Cos theta equal to 1 by 2. Cos theta equal to adjacent side by hypotenuse. This is the formula. In the numerator we have adjacent side and in the denominator hypotenuse. Therefore, for cos theta equal to 1 by 2 will be, the numerator will be 1, that is adjacent side is 1 and the denominator is hypotenuse and its value is 2. In a right angle triangle, we are given the length of the adjacent side and the length of the hypotenuse. We were not given the length of the opposite side. We are going to find the length of the opposite side by using Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square, and this is named as equation 1. Put adjacent side equal to 1 and hypotenuse equal to 2 in the first equation. On substituting these values in the first equation, we get 1 square plus opposite side square equal to 2 square. That is, adjacent side value is 1 and hypotenuse value is 2. These values were substituted here. Now 1 when square it will be 1 plus opposite side square equal to 2 when square it will be 4. Now on the left hand side we have opposite side square, and on the right hand side we have 4. When this plus 1 goes to the right hand side of the equation, it will be minus 1. Now left hand side is opposite side square equal to 4 minus 3. 4 minus 1 will be 3. Taking square root on both sides, we get root of hypotenuse opposite side square equal to root of 3. When root of opposite side square comes out, it will be opposite side equal to root 3. Hence, we have found the length of the opposite side by using Pythagoras theorem. Now, let's see the third problem. Tan theta equal to 8 by 6. For tan theta, we have the formula opposite side by adjacent side. The numerator is opposite side and the denominator is adjacent side. So for the given problem tan theta equal to 8 by 6, the numerator is opposite side, that is opposite side equal to 8, and the denominator is adjacent side, that is adjacent side equal to 6. In a right angle triangle, we were given the length of the opposite side and the length of the adjacent side. We were not given the length of the hypotenuse. We are going to find the length of the hypotenuse by Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. And this is named as equation 1. Put the adjacent side equal to 6 and opposite side equal to 8 in the first equation. On substituting these values in the first equation will become 6 square plus 8 square equal to hypotenuse square. 6 when square we will get 36 plus 8 when square it will be 64 equal to hypotenuse square. On adding 36 and 64 we will get 100 equal to hypotenuse square. This hypotenuse square is brought to the left hand side of the equation and 100 is brought to the right hand side. Taking square root on both sides, we get root of hypotenuse square equal to root of 100. When root of hypotenuse square is coming out, it will be hypotenuse equal to, when root of 100 is coming out of the root, it will be 10. Hence, we have found the length of the hypotenuse by Pythagoras theorem. Now, let us go to the fourth problem. Cosecant theta equal to 5 by 4. For cosecant theta, we have the formula hypotenuse by opposite side. The numerator is hypotenuse and the denominator is the opposite side. For the given problem, cosecant theta equal to 5 by 4, we have the hypotenuse as 5 and the opposite side denominator is 4. Hence, in a right angle triangle, we were given the length of the hypotenuse and the opposite side. The length of the adjacent side is not given. We have to find the length of the adjacent side by Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse. That is, adjacent side square plus opposite side square equal to hypotenuse square. And this is named as equation 1. Put opposite side as 4 and hypotenuse equal to 5 in the first equation. On substituting these values in the first equation, it will be adjacent side square, because this adjacent side value is not known. We are going to find adjacent side square plus this opposite side is given as 4 and it is square equal to hypotenuse is given as 5 and it is square. That is, adjacent side square plus 4 when square equal to 16 equal to 5 when square it will be 25. Now this adjacent side square is kept on the left hand side, and on the right hand side of the equation we have 25. When this plus 16 goes to the right hand side, it will be minus 16. Adjacent side square equal to 25 minus 16 will be 9. Taking square root on both sides, we get root of adjacent side square equal to root of 9. When root of adjacent side square is coming out of the root, it will be adjacent side equal to, when root of 9 comes out of the root, it will be 3 cm. Hence, we have found the length of the adjacent side by Pythagoras theorem. Now we shall see the fifth problem. Secant theta equal to 10 by 8. For secant theta, the formula is hypotenuse by adjacent side. The numerator is hypotenuse and the denominator is the adjacent side. Hence, for the given problem, secant theta equal to 10 by 8, the numerator is 10, that is hypotenuse is 10, and the denominator adjacent side equal to 8. In a right angle triangle, we were given the length of the hypotenuse and the adjacent side. The length of the opposite side is not given. We are going to find the length of the opposite side by Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse, that is adjacent side square plus opposite side square equal to hypotenuse square, and this is named as equation 1. Put the given values adjacent side equal to 8 and hypotenuse equal to 10 in the first equation. On substituting these values in the first equation will become 8 square plus opposite side square is written as opposite side square equal to hypotenuse square is written as 10 square. When 8 is squared, we will get 64 plus opposite side square equal to 10 when squared it will be 100. Then on the left hand side we have kept opposite side square equal to 100 is on the right hand side and it is written, and when this 64 plus 64 goes to the right hand side of the equation, it will be minus 64, that is opposite side square equal to 100 minus 64, that is opposite side square equal to 100 minus 64 will be 36. Taking square root on both sides of the equation, we get root of opposite side square equal to root of 36. Root of opposite side square when comes out, it will be opposite side equal to, and when root of 36 is coming out, it will be 6. Hence, we have found the length of the opposite side as 6 cm by using Pythagoras theorem. Now we are going to see the sixth problem, cot theta equal to 4 by 5. For cot theta, we have the formula adjacent side by opposite side. The numerator is adjacent side and the denominator is opposite side. For the given problem, cot theta equal to 4 by 5, the numerator adjacent side equal to 4 and the denominator opposite side equal to 5. For the right angle triangle, we were given the length of the adjacent side and the length of the opposite side. We were not given the length of the hypotenuse. We are going to find the length of the hypotenuse by Pythagoras theorem. Pythagoras theorem states that the sum of the square of the adjacent side and the opposite side is equal to the square of the hypotenuse, that is adjacent side square plus opposite side square equal to hypotenuse square, and this is named as equation 1. Put the given values adjacent side equal to 4 and opposite side equal to 5 in the first equation. On substituting these values in the first equation will become 4 square plus 5 square equal to hypotenuse square, that is our adjacent side is replaced by 4 and it is squared plus opposite side is replaced by 5 and it is squared equal to hypotenuse square. 4 when squared it will be 16 plus 5 when squared it will be 25 equal to hypotenuse square. Now 16 plus 25 will be 41 equal to hypotenuse square. This hypotenuse square is brought to the left hand side and this 41 is brought to the right hand side. Now taking square root on both sides, we get root of hypotenuse square equal to root of 41. Root of hypotenuse square when comes out of the root, it will be hypotenuse equal to root of 41 is written as root of 41. Hence we have found the length of the hypotenuse as root of 41 units by Pythagoras theorem. Now we are going to see the last question, that is, what is the use of learning trigonometry? Trigonometry is used to find the height of the building and in the fields of construction, physics, marine biology, marine engineering, archaeological department, and in navigation and aviation industries. Trigonometry is used to find the height of the building if a person is standing at a known distance from the foot of the building, seeing the top of the building with the known angle theta using the trigonometric ratio. From the given diagram, let AB be the height of the building, C be the point of elevation of the top of the building B, angle ACBB theta. We know that the building is perpendicular to the ground, that is AC is perpendicular to AB. Therefore, angle A equal to 90 degree. We know that the side opposite to theta is the opposite side, that is AB be the opposite side. The side opposite to 90 degree be the hypotenuse, that is BC be the hypotenuse, and the third side after naming the opposite side and hypotenuse will be the adjacent side, that is the side AC be the adjacent side. We have to find the opposite side, that is we have to find the height of the building. The trigonometric ratio related to the opposite side and the adjacent side is tan theta, that is opposite side by adjacent side equal to tan theta. Now opposite side equal to tan theta. By cross multiplication we can take this adjacent side to the numerator, that is tan theta into adjacent side. In this equation we have to apply the theta value here and this adjacent side distance here. After finding the tan theta value and multiplying the tan theta value by adjacent side, we can get the opposite side, that is height of the building can be found. Hence height of the building can be found by trigonometry. After watching this video, mail your doubts to mathsmastermano@gmail.com. Like, share and subscribe Maths Master Mono YouTube channel. Thank you.